So hi and hello. Welcome to our channel named Lego Exploration. My name is Samir and today we will going to learn about binary search. So let's get started. Now, when we want to search the meaning of a word, we generally use to search in a dictionary, or when we want to get contact, we search in a contact list. If the data is sorted, then searching becomes easier. So we can say that if the data is sorted, then the searching becomes easier. Let's take a practical example and see how. Let's say we have a book of 100 pages and we want to go at the 75th page. So we randomly open a book and let's say we are at 50th page. So we will go at the right side, not the left side, because 75 is greater than 50. Similarly, observing this behavior, we introduce a binary search. Let's say we want to search for a number 70 in this array. Now, this is the start and this is the end. We first find the mid position. Now, to find the mid position, here is the formula that start plus end divided by 2. Now, to find the mid, here the start is 0 and end is 9 divided by 2. That will be 4. So, we will search at A of 4 whether A of 4 equals to 70 or not. Since A of 4 is 40, which is not equal to 70. So what we will do, we will search on the right side from 50 to 90. So the start will become 5 and end will be as it is 9. Now again we will find the mid position from year to year. So the start is 5 and end is 9, that divided by 2. So 5 plus 9 will be 14 divided by 2, that will be 7. So whether A of 7 is equals to 70. Yes, it is. So we found the search at A of 7. Now how many comparisons do we do at here? We do only 2 comparisons. What if we do the searching using the linear search? Then we will search the element linearly, whether 0 is equals to 70 not, 10 is equals to 70 no, 20 is equals to 70 no, 30 no, 40 no, 50 no, 60 no, 70 yes. So we actually we do comparison of 8. So which one is better? Here the binary search is better when the data is in sorted manner. So therefore we can say that if the data is sorted, searching becomes simpler. Now here we have to find the mid always. Now my first question is that why we have to go at the mid position only. Let's take an example and see it. Let's say we have 10 elements from 0 to 9. So 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. And we want to search the element that is 6. Okay. Now we will take 2 cases when mid is n by 3 and when mid is n by 2. Now to find the mid, so 10 by 3, that will be 3 only. So we will go at third position. Since 3 is not equals to 6 and it is smaller than 6, so we will neglect this part. So we are actually neglecting only 4 elements. Now let's say the mid is n by 2. So 10 by 2, that will be 5. So this one is better. Now I hope you got why we go always at the mid position only. Now let's take an example and see. Here this is the array and we want to search for the element 31. Now representation of what is start, end and mid. Okay, now there are actually three cases. After finding mid, we will just check whether if mid is equals to a of mid is equals to x or not. If it is, then we will return mid. So we got the element at this position only. The second case is if the mid a of mid is less than x, then we will actually neglect the left part because a of mid is actually lesser than x. So we will neglect this part. Now the third case will be if a of mid is greater than x. So value is actually in this part. So we will neglect the right part. So in this way we actually do binary search. Now let's find the value 31 in this array. Mid, start and end. Initially the start is 0 and end is 9. So we will calculate mid. That will be 0 plus 9 divided by 2. That will be 4. Now we will check whether a of 4 equals to 31 or not. No, it is not, because a of 4 is 42. That means the value we want is on the left part. So we will neglect from 32 to 88. Okay. Now again we will calculate. Here the start will be as it is 0, but the end will be changed, that is 3. And again we will find the mid. 0 plus 3 divided by 2, that will be 1, and we will check whether a of 1 is equals to 31 or not. A of 1 is nothing but 19, which is not equals to 31. So we will neglect the left part. Now that is we neglect from 30 to 19. Now the search space is this one. So the start will be 2, end will be as it is 3, and we will find mid again. So 2 plus 3 divided by 2, that will be 2. A of 2 is equals to 31 or not. A of 2 is 27, which is not equals to 31, and 27 is less than 31. So we will neglect again the left part. Now again we will check. Start will be 3, end will be 3, and 3 plus 3 divided by 2 will be 3 only. Now we will check whether a of 3 is equals to 31. Yes, it is. So return 3. So at third position we find value 31. So in this way we actually find the element when the data is in sorted manner. Now let's see about the pseudocode. This is the function name, binary search recursive. We are passing array A, target element low and high. You can consider low as start and high as end. Now we will check whether low should be, we will check whether low is greater than high or not. If it is, then we will return false. Or else we will first find the mid, low plus high divided by 2. Then we will check whether a of mid is equals to target or not. If it is, then we will return true. Or else if a of mid is greater than target, if it is, then we will actually neglect the right part. Or else this is not the case, then we will neglect the left part. So this is a simple pseudocode. Now let's see this time complexity here. This is a small problem. This is nothing but divide. And this part is nothing but conquer. Now what will be the combined? Here there is no combined. Because we are dividing the search space and we don't need to combine actually. Because we are searching in that part only. Like we are dividing and then we are again dividing and again dividing and again dividing, and we don't need actually after dividing we don't need actually this part, so we don't need to combine also. So there is no combine actually, there is only divide and conquer. Now what will be the recurrence relation? T of n equals to, since we are calling the function 2 times after dividing, so that will be 2t n by 2 plus c. Here c is nothing but cost for divide only at first level. Now here is a twist, that here we are not actually calling both the functions, we are only calling one due to the if else case. So this will be not 2, this will be 1. I hope you got that. Now so the recurrence relation will be Tn equals to T of n by 2 plus c, where c is cost for divide at only at first level. Now let's find the time complexity using the master theorem. Here a is 1, b is 2 and f of n is c. So n log a base p and f of n. This will be n log 1 base 2 and this will be c. N raised to 0, that will be 1, which is nothing but c only. So both are equal, therefore it will be c into log n. Therefore we can say that it is nothing but order of log n. So the time complexity for binary search is nothing but log n.